Hello everyone. So now that fun is all out of the way, I'm going to get into the more technical aspects of this project. So first there's a little initial terminology that we should go over about meshes. Specifically, a vertex is just a point in space, and we can think of this as a vector because that's how they end up being represented in NumPy, which is what I'm using for this project. An edge just connects two vertices, so it's a line connecting 2 points in space. And then a face, for our purposes, is an individual triangle, but you can think of it as defining the sides of an object. And then we also need to define a parameterization. And so basically a parameterization is some mapping of vertices to the 2D coordinate plane. And what I mean by that is at any point on the coordinate plane, if you plug that into some function f, those coordinates as input to function f will then give you a 3D coordinate on the mesh. And seeing this visualized will hopefully clear up what I mean. Lastly, you need to also know that the genus of a surface is just the number of holes in it. And for this project, our goals are to load a 3D object, parameterize it into the 2D plane, and then also we need to quantize every vertex position on the 2D plane so that we can put it all into an image. And if we actually go ahead and do this next step, then what's going to happen is we're going to take every x, y, and z coordinate. So each point here represents in our function an x, y, and z coordinate, and we're going to represent those as r, g, and b values. So just between 0 and 255, where r is x, y is g, and z is b. And then we're going to save our image. And we can do the exact same process in reverse to recover our image. So the problem with this is that it actually takes a little while to execute. This is a relatively small mesh, and you can see it's taking a long time on my computer. So this step is definitely not in real time. And it's worth noting that in the original paper, the cut is actually supposed to be refined so that the mesh can be more efficiently rendered with the same file size. But this doesn't do that, and it's still slow. So I won't show what the final image actually looks like, because if you stick around to the end of the video, it gets shown in the final demo. But I will show that when we reconstruct our mesh, this is what we end up getting. We end up getting this head that's slightly more deformed, but you can see this is from a 256 by 256 image, which is 23 kilobytes. And the original file storing this is actually 767. So we did manage to lossily compress our mesh quite well. So I'll let the demo take the rest of it away. Hopefully you enjoyed this.